Hello. Let's continue hypothesis testing, part 2. Outline. One sample z-test, one sample t-test, paired sample t-test, independent samples t-test. So basically, we're gonna just discuss this very simple hypothesis test, so that you can see how hypothesis tests are done. Okay, so they're really basic, but they're very informative because the steps for doing hypothesis testing is most similar. Okay. So before we even start, let me just emphasize a few things here. First is each statistical test has its assumptions. Okay, and the test results are not reliable if the assumptions do not hold for your data. So you really have to have the maturity for understanding the assumptions of a statistical test and verify whether your data actually meets these assumptions so that you can have some faith in the hypothesis test results. Okay. And two factors for selecting the appropriate statistical test. One is study design, and the other is the level of measurement. Okay, so when you think about doing hypothesis testing, there's hundreds and thousands of different statistical tests. So which one you're going to use, right? So that is half science, half art. You have to practice a lot to get a good sense of it. But if you think really carefully about the study design, how did you set up the study? For example, whether it's a paired study design or independent design, okay? So for paired design, maybe you have a pre and post design. So your data comes up in pairs. So that structure determines you have to use paired t-test or McNemar's test, okay? And the level of measurement, whether your data is, say, dichotomous, or it's ordinal, or it's interval. So this kind of thing also determines which statistical test is appropriate for your data. Okay, and you'll get better over time after practicing more tests with different types of data. Okay, now let's talk about the one sample z-test. So the assumptions of the one sample z-test is one, data from a normal distribution n with mean mu and variance sigma squared. And the second assumption, the true variance of the normal distribution sigma squared is known. Okay, so this is a little bit unrealistic, but well, just for the presentation here, we just assume sigma squared is known. Okay, so we mentioned hypothesis setting starts with a pair of null hypothesis and alternative hypothesis. So for the one sample z-test, H0, the null hypothesis, mu equal to mu 0. So mu 0 here is a known value. So we're testing if the true mean equal to certain specified value. Okay. And the alternative hypothesis, now here, there are some variations. One is H1 or HA can be mu not equal to mu 0. So this we call two-sided because you don't know whether it's greater than or less than. Okay, so it's two directions. Or you can have HA as mu greater than mu 0 or HA is mu less than mu 0. It's one-sided. Okay. So you have two-sided test or one-sided test based on the alternative hypothesis being two-sided or one-sided. Okay, and then the next component of the hypothesis is you must pick a good test statistic. So here is the Z statistic, which is computed using the formula on the right. So it's x bar minus mu 0 divided by sigma over square root of n. So here x bar is the sample mean, mu 0 is the specified value, hypothesis that's the value for the mean, and sigma is the known variant, standard deviation here, and n is the sample size. So here, just pay attention that both mu 0 and sigma are known. Also, sample size n is known. So you calculate these statistic from the data, then you compute the statistic. And we said all the test statistics has nice properties. For example, under the null hypothesis, they have a known distribution free of any unknown parameters. So for the one sample z-test, the null distribution is the standard normal distribution, n01. So it's a normal distribution with mean 0 and standard deviation 1. Okay, now we come to the decision-making step. So we need to make decisions. We need to come up with a decision rule. So for critical value method, we reject H0 if Z, the test statistic value, is less than negative Z alpha, or Z greater than Z alpha, or the absolute value of Z is greater than Z alpha. Okay, that depends on the one-sided or the two-sided alternative we're testing. Okay, or you can use a p-value method. So basically, using the test statistic and the null distribution, you can calculate the p-value, and you reject H0 if p is less than alpha. Okay. So here, reject H0 is not a really absolutely correct way to say it. So a more politically correct way is to say fail to accept H0. Okay. Some people may make a big argument if you say reject H0. Okay. So reject H0 doesn't make H0 false. Okay. Remember type 1, type 2 error. Right? Okay, so I'll just provide the links. Please, review these videos for the PSS implementation of one sample z-test. Okay, let's move on to the t-test. So we're going to cover one sample t-test, paired sample t-test, and independent sample t-test. So assumptions of one sample t-test: 1, data from normal distribution mu sigma square. And the true variance of normal distribution sigma square is unknown. Okay, so this is more realistic. When we're given a sample of data, we don't know the true variance of the population. Okay, and the hypothesis, the null and the alternative hypothesis are very, are the same as the one in the one sample z-test, right? And the test statistic here is called the t-statistic. And its formula is on the right-hand side. The t-statistic equal to x bar minus mu 0 over, now s, over square root of n. Here, s is the sample standard deviation. Okay, there's a formula to compute s squared, and you take a square root, you get s. Okay, and just remember these, all these sample mean, sample standard deviation s, and the sample size n are computed from the data. Okay, so they are computable. And the null distribution is a t-distribution with degree of freedom n-1. So when we talk about probability distributions, we talked about the t-distribution. Okay, the t-distribution is a very unique distribution. When the sample size is greater than 30, the t-distribution and the z-distribution are hardly distinguishable. So here you can see the graphs. When it's going over going to infinity, actually going more than 30, you really cannot tell the difference between the two curves. So that's why with larger sample size, we can actually, the z-test is actually pretty close to the t-test result. And decision-making rule, we can use the critical value method, but here you need to find the critical value using the null distribution, the t-distribution with degree of freedom n-1. And of course, based on one-sided and two-sided alternatives, you need to decide whether it's a 1 minus alpha or 1 minus alpha over 2. Of course, if you compute p-value, then you just get the same rule, reject H0 for p is less than alpha. And of course, the politically correct way is say fail to accept H0. So basically, the one sample t-test is very easy to do in SPSS. Just click Analyze, Compare Means, and select one sample t-test. And then you can get the output look like this. So one part you get one sample statistic. Basically, they're descriptive statistics with sample size, mean, standard deviation, standard error mean. And then you get another table that's a test result. You get mu0, t, and degree of freedom, p-value, mean difference, and even 95% confidence interval for the mean difference, okay, for the mean actually. Here's the video. Watch that. It's a good video showing all the steps. Okay, so I'm gonna go a little bit faster. So just go over the paired t-test, its assumptions. Data are paired and from two normal distributions, n mu1 sigma squared and n mu2 sigma squared. And the true variance of normal distribution schema is unknown. And now the null hypothesis h0 mu1 equal to mu2. Alternative hypothesis can be HA mu1 not equal to mu2 or HA mu1 greater than mu2 or HA mu1 less than mu2. And the test is a t statistic. So basically for paired sample t-test, you get paired data, you calculate the difference of each pairs. It reduced to one sample, and you actually just use the one sample t-test on that new paired sample. Okay. So I'm gonna just go over these slides pretty quickly. They're very similar to the previous one. And it's also well implemented in SPSS. Okay. So the last one would be the independent sample t-test. So this test has assumptions. One, data independent and follow two normal distributions. And the true variance of the normal distribution sigma squared is unknown. And the null and alternative hypothesis are very much like the paired sample t-test. So you compare the two population means. And now the t-statistic for independent sample t-test is showing on the right-hand side. So it's x1 bar minus x2 bar minus the difference between mu1 and mu2 divided by SP is the pooled sample variance, then times square root 1 over n1 plus 1 over n2. So n1 and n2 are the two sample sizes. If the sigma 1 square and sigma 2 are not equal, then you use another form of the t-statistic. Okay, and this is going to be there's going to be Levene's test for testing whether H0, whether these variants are equal. So I'm going to just skip all these, and so here's the output. You can see the statistics, and you can see there's a Levene's test, and there's the t-test result. Okay, and here's the videos. Please make sure you watch those, and thanks for watching.